You can start.
Yes, so good evening once again, and you're all welcome to tonight's class. This is more manual testing, software testing class. I still remain your tutor, and my name is Yemi Ayola. And I'm so happy to have you all. So I believe those of you have joined the class, you're part of the team QA. Well, these are the topics that we are going to discuss in details in terms of breaking them down in granular level, step by step. And in this session, um, what I always like or my advice to you all is just listen carefully, take some jottings. Of course, you can still rewatch the videos, and also make sure at least you're listening to most of the points that I'm bringing out. And likewise, attention is the key thing. And every assignment you're given in this class, please make sure you do them. Don't pile your assignment, don't pile your videos. Watch them step by step and make sure you're able to get it. At any point in time, if you have any questions, so that you don't forget it, just pop it in the chat. We have our colleagues, they are there to answer your question. And when I finish, I also will do Q&A session and we can actually talk more about the question. So that's me. So the topics that I intend teaching in this class, it's just a subset of everything, but they're going to be in details now. So the first one is that I'm just going to give you more background of testing, just for you to have an insight, just a big one. The next thing I'm going to talk about is fundamentals of testing process, which also comprises of general principles of testing. Likewise, that's the testing principles. I'm going to talk about the test processes, and I'm going to talk about the code of ethics. So that's me literally regarding that, and it will be Q&A session. So these are the topics again. So just for you to know that this is what we are going to work on. Now, I would start about the background. Initially, when we did the introduction to software testing, I gave some examples. Now, we want you to just to have a clearer view and also bring you back to reminder of what background is, the background of testing, with the necessary things, the reason why we have to test. So all those points are what we are going to bring up to actually talk about in this session. And I will now lead you to where the the fundamentals, the reason, the exact reason, and what is expected for us to do. So now take the background. I took an example of a new car. Let's say you want to buy a new car now. You won't expect to go to the delivery showroom like a car, just any brand of car. And when you get there, you don't want to get to the showroom and see that one side of the car is scratched or is broken. You can't even, there's no door by the side of the car. You won't take that car. You want a clean car, a car that's got four four doors. It could be two doors. You know the specification of what you want. A car that's got maybe 5 wheels. That's including the extra. A car that's got a steering wheel. It's got an engine. All necessary components of the car are in the car. So you don't want to, and that's the reason you go to a showroom to test run the car. You enter the car, you check, or when you start it, is the engine sound? Can you move it around? Just test driving to see. It's a form of testing. anything. I believe that there's nothing that you want to do again that testing is not involved. If you want to drink cold or hot water, you can test is you testing the water too. Like you've made hot tea now. You don't want to take that hot tea and just sip it all. You to burn your tongue. So you test, oh, is this the level? Okay. Oh, it's too hot. Let me blow it. You had lot another air, you take it, oh going. What you're doing in that process is that I've tested it. Oh, it's too hot. Let me wait a bit. Let it cool down. I'll test it again. Wait a bit, it cools down. So there are various forms of testing that we have a lot. And I think most of the things that we do, we test it. It's just like you're going to, if you've ordered a clothes or a dress, even if you know your size exactly, you still want to test if the dress fits you, if the appropriate, if you like the fitting. If you don't like it, you won't just buy one and just peel it out if you've not tested the clothes. So all these are various ways. There are more backgrounds in testing, and there are several examples in the software textbook, the soft copy that we have. There are various examples. I think page 7 to 10 will tell you lots of examples, the reason why software fails, and all those examples. And please just find it and try and read that textbook. Likewise, the next thing is our objectives. What are our major things here? What do we want to do? We are going to talk about what testing is. I'm going to give you how it is done. I'm going to tell you what is testing, why testing is necessary, and likewise general principles of testing. So the fundamentals of testing and all these are the objectives we are going to look at. Testing. What is testing? I've said so much about what testing is, how testing is going to be carried out. All this we want to know more about it. So what is testing? This is an activity that is performed to demonstrate that something is working as expected. So we are expecting something that is working as expected. Give example of you've got a laptop. You've just got to you want to get a laptop. The first thing you want to check is this laptop working? You switch it on. It's on. Does it have the necessary things that I need in the laptop? Like for example, while you were purchasing a laptop, I could remember one of the specification that you were told was that get a laptop of this specification. It should be 5 RAM. It should be this. Check this. So all these are various forms of testing. You are checking if the testing, the laptop is according to your specification. If you take a laptop that you can't use to download the applications that you're going to use here, it's more or less like you've wasted your money. So, hence, you need to test, you need to know the capacity of your laptop before you use it. That's the reason why we test. We test to ensure that whatever we have is working as expected. Now, we are going to lead into software world. There are various applications. So when they mean that you want to test to make sure that something is working as expected, I take for example a Google page. It is like an application that you want to test if it's working as expected. What is your expectation? The first thing is that of course you have your machine that you're going to use. That's your laptop. The first thing you do is that you need the endpoint. What's your endpoint? Your URL www.google.com. Then when you get there, you want to do some things there. You want to be able to check, maybe go to the BBC News, go to several components of that place. Then you are able to see that that software is working. Let's bring it closer to ourselves. You are in Blue Sky now, receiving training. Take an example of when you wanted to join Blue Sky. I know that most of the time there are some various links that you would have gotten. But the first thing is that you go to Blue Sky homepage. When you get to Blue Sky Citadel homepage, from there, you want to check, oh, they do. They do training. They said they do this training, this training, this training. You look at all the lists: software, business analyst, scrum master, development, project management. So all these are things that are being done. Now you want to know, which am I going to do? Okay, I've looked at it. This is various companies. All this form, what you are currently doing at that time, you are actually testing. You are looking at it. Is it what I want to do? So various methods, various ways that we do testing. So what can be tested? Hardware, software. Hardware, physical devices, something you can touch, like your laptop, and software, something you cannot see, just like the internet browser, the games. So again, it's testing for me. Let's find out. As long as you are, as long as you can do everything that I've said initially, you can check your car, you can check if water is hot or cold. You can check your tea, you can check your food, you can check your pen, you can go to a website, you can play with it. Then, to be honest, you're in the right place. Testing is for you. So, a good software tester, I also mentioned it. All these are things. The reason why I'm reminding you of everything is for you to know that you have the class you are in now is more of a class where you get everything in full. So, good software tester, these are the main skills that you need. You must have verbal and written communication, good one. Reason for this, I'll explain, is, for instance, if you find an issue, like you have gone to the car shop, you have seen that one side of the car, the door is removed. What you do immediately is that you want to reproduce that system to say that that the side of the car is broken. How do you do that? Then you start by saying the title of what you have seen, broken side of the car. That's the title. Then you want to reproduce it. When I got into the showroom, I was taken to the car. The next thing, by the side, the left side, the old door is removed. It's cried. Just that line. Now, if I want to retest, I'll also look at it. It's broken door. I will walk down to the car you have said, put the registration number, you have all the details you have put in the box. I will put all the details. Then immediately I'll go to the car, I'll check the side. Then if it's been fixed, then that's you writing what you have seen, how you found the bug. That's the written part of it. What's the communication part of it? I have found the bug. You want to relate it to the team. How did they find it? You need the same way you're saying it, you just to explain it in words to people so that everyone understands it. If you read something, if it makes meaning to you and someone else picks it, it should make meaning to that person. That's the reason. Then you must have the passion. You must have the passion for whatever you want to do. You must have the technical skills. That's why you're here. You must be analytical. You must have the attitude. You must be productive. All these are the things that we do in our day-to-day life. There are the things that you yourself, as a software tester, you need. Now, the next thing is that what is software testing? Is still taking you back to say, this is the activity that is an activity that is executed to demonstrate that software What did I call a software? I've given you several software. Software could be a package, it could be a program, it could be a system, it could be a mobile application, it could be a web application. Mobile application, take for example, you are testing a mobile phone, like the Android, like your normal phone. If you got an Android, iOS, any form of mobile phones that you have, we have emulators, that tools that you can use to test, do mobile testing, and you will be inserting everything via it. Then you have physical device. What is the mobile application physical device? You have a phone currently, everyone does. That phone is a physical device, is a mobile application. Web application, I've given you example, take Blue Sky, take Google, take any application that you can. There are different packages, there are different software, there are different systems. Major thing is that it's working as expected. I know your mind will be asking me, why am I saying working as expected, working as expected? Now, your expected determines what the requirement is. It is not your own expectation. What I mean is that it's not what you feel that it is right. It is what exactly that you have in the requirement document. You validate against it. So, for example, if in the requirement document, when they were telling you to order a laptop, in the requirement, it was specifically stated that take a 4.5 RAM or a 2 RAM. That is what it said specifically. You can't go for, because 5.5 RAM is very good. That's what I'm going to use to do. No, that's not what it is stated in the requirement. It was specific to 2 RAM. You have to follow the requirement. That is what it means. It works as expected. Your own expectation might be, oh, it is small, it's meant to be 5. That is your expectation. But the requirement, what the business wants, what the client wants is 2. That ends it. So that 2 should be it. Then we have negative scenarios, we have positive scenarios. All that we are going to come into it when it comes. Software testing is not complex. It is not difficult to implement or execute and practice. Software testing is a discipline, it's a job, it's a title. That is what it means. So, why we need to test? Why do you think we need to test? With all the examples that have been given, you will see that it is kind of vital. We need to test. Everything you need to do, you need to test. So the reason why you need to test is to ensure that what we create does what it is supposed to do. I've just explained to you 4.2 RAM is the expectation. It has to be it. So we need to be sure that, yes, to ensure that what we create is what is supposed to do. So if we were told, if you are given a project in Blue Sky, it says register, follow this link and register. If you don't follow the link, you won't be able to register. That is it. So the expectation is that when I click on the link, it should lead me to registration. That is the expected. So that is what is meant to do, to ensure that what we create does what it's supposed to do. The next thing is that something that works when one person is using it may not work when hundreds of people are using it. That's where types of testing, the process, the way we are going to do is going to come in. So now you might be using a website and it's working perfectly when only you are testing. When you add force to it, 10 people, it changes a bit. If it was fast, very fast, by that time it will reduce. Now take it concurrently again, add like 100 people to it again. So the way it will react might be different. So all this has to be in consideration why when we are testing. That is the reason why we have to check it. One user, like now in Blue Sky, when we started the website, it will be fine when it's one person. Now look at it. Thousands of people are going into the website, looking at what we do. At that stage, there are a lot of force going there together. 500 people can be using it at the same time. We need to cater for that so that when 500 people are using it, 1,000, 2,000, millions of people are using it. It doesn't crash. So all these are the reason why we need to test. At that phase, performance testing, which includes the volume testing. Is anyone talking? So that's the reason why we test. Then the third reading again is there's always a chance that the user really will do that no matter how silly it seems. So you might think that when a user wants to log in, he or she, you are taking a login functionality. You might say username. Why can't someone know that username cannot be numbers? No. I can go in there as a user and put 1, 2, 3, 4. It is me. So we should cater for that. If we don't want numbers to be there, it should be part of the error messages that will be displayed. That's the reason why we need to test for it. So if the client or whatsoever developing the application for wants username to be this, the specification will be there. It will be stated in the requirement document. Hence, we need to check all the processes. Then there are lots of different devices, browsers, and operating system out there. So as you have said, you've got several devices. Look at Android phone. There are several versions of Android phone. Talk about um, iPhone. A lot of them. We've got a lot of them out there. So the way each of them behave is kind of different. The way you will see contents in iPhone 6 will be different from the way you will see it in iPhone 14. So all those variation has to be tested properly so that we have the right content, so that everyone that is using the application, we are meeting their needs. So what you're trying to say now, what I'm trying to say is that, for instance, we want to test this Blue Sky so that someone is able to log in Blue Sky on iPhone 6. If it's not working perfectly in iPhone 6, so it means that you have lost money, you have lost a lot of people that are using iPhone 6. It might be a small subset that is using iPhone 14 that it works perfectly on. So you have to be able to cater for everyone. That's the reason why we have to do different types of testing. We are doing on devices, browsers. We've got different browsers. We are talking about, you've got the Chrome, you've got IE, Firefox, Safari, everyone. So there are different ways, different operating systems out there. Hence, we need to test. We owe it to our users and ourselves to deliver the best application. That's why we need to test. So, is so we test to avoid, the reason why we test to avoid software failure. We test that the system needs to be adequately tested and the right sort of testing needs to be done as well. We are going to talk about that too in our topics. The consequences, if we don't test properly, it could be loss of money, loss of time, loss of business, reputation, injury, and death. So there are different levels of testing, which we are going to talk about also in this. So now I've brought error defect failure because these three are the are the main thing you are going to be doing when it comes to testing. This is one of it. Defect. Defect. You are defect. You as a tester. Let me just say your major money is on defect. You have to find the fault. You have to break the system. You have to break the application. That is the reason why you are employed as a tester. You must have good eye for quality. You must have be able to find every little error that people can't find. So that's the reason. So these three is just a deeper knowledge of what these three does. Now, error. Error is a mistake. It leads to a defect, which can which can cause an observed failure. So all these three are error starts one, defect going. When you find an error, you found the defect, then you found the failure, then it results into a failure. Then what is error? Error is human mistake. An error, error might not be in the code. It might be anyone in the team that can make the mistake during any phase of development. Mistake happens. Is human that are actually developing. You as a tester, you're also human. The user giving us the information is also human. The business requirements, the business analyst is same person. So we all, anyone at any time can make mistake. Examples of error. What are the examples? At what level are these errors done? Who can make who can make the error? It could be the business analyst. Maybe they've misinterpreted the requirement. So maybe the business analyst or he or she might think, oh, um, maybe what it means is this. And whatever the business analyst gives to a developer, gives to a tester, is what we'll test against. That's why we also need to do static testing to check if the requirement is right. We have a clear understanding of the requirement before it's being done. It could be the customer. The customer they might not know the application. I'll give you an example. I'm working on a project where you nobody has a clearer picture of how the application works. They only use it. They do their day-to-day activity on this. Now, if you call a stakeholder in to say, what do you exactly use this for? The first person can give you, this is how I know how to use it. That is just it might just be the little part of what the application does. The next person too might just tell you just a small subset of what the application is meant to be doing. So there might not be sufficient information. So if the customer, if they don't understand exactly, they don't have much information. So as development is going on, that's why Agile is there. We will now be saying how it is working, then corrections could be made, requirements can be accommodated, the builds are being done, then we'll start giving it to them, they'll be checking and bringing back. That's it. So it could also be the architect, the solution architect could also maybe give us a design that is from the understanding of what they have to on the design. So those are the kind of people that could make mistake. And also, we as team members, we might not be sure of some requirements, and maybe due to pressure, due to tiredness, other things could result in error. So error could not is not generally to say error is caused by this person. So that's the way, that's the example of error. So defect is inconsistency between expected and actual results. Always remember, I keep telling you these two words, expected, actual, all through your testing life. As long as you're taking your career as a tester, your two words will be expected, actual result. That's the way we talk. Expected result, actual result. This is it's you can't say anything without these are terminologies that we use when it comes to testing. And while I'll be teaching you, I will be taking it from you getting understanding in a real world and also moving into um, testing words, because those terminologies have to flow. So expected is the normal, your normal expectation when you mean the English word. The thing with testing is that all they are English words that, if you look at the meaning, it is actually what it is when it comes to testing. Expected. What is my expectation? How do you know your expectation? Let's go back to the world of the laptop when you were told to order a laptop. Now, there are various laptops out there. It's now the RAM, the capacity of what you need. That's what determines laptop. It's not the size now. You need to know what the engine is, the big parts. So now, you know, I as a person, I'm a software tester. I'm going to use my laptop, or I'm a developer. I'm going to use it I need some specific applications on it. I need to use some tools that are kind of powerful. So they need big RAM to be able to accommodate that. I, as a tester, my expectation will be this is what I want. Now, that is my own personal expectation. Is it what the client wants? Now, let's go back to the requirement. I'm now going back to the business analyst. So the requirement is being gathered either by the product owner, or that's the PO, or the BA, which is the business analyst. They gather the requirements. The business analyst does a job, he or she does a job to say specifically your laptop should have 5 RAM. Your laptop should be this size. They've specified it there. Now, when you want to write your script, that specification itself, laptop size should be 5 RAM. So you have to go to settings. You have to check it to be sure that is the exact one, and you take a snapshot. That it was, because once you take a picture, nobody can argue with you when they see picture. It's just like taking a picture of yourself. Is what is in the picture. That's the way your face looks. So when you take the picture, you can't argue with it. If you're wearing blue when you took a picture, it's blue that is going to show in the camera. It can't show red. It's impossible. So whatever you have taken as a picture is what it will be. So that's your expected, your actual. Now I am on blue sky. The link I've been given, is it exactly? Yes, it's exactly. That is it now. I have the application. So actual, always remember, actual is that you have the exact thing, the exact application, the exact product to work on, the exact system to work on. That is when you take your actual result. Expected are from what you have gathered from the requirements. It's a prep before then. Now, defect in software product reflects the inability of the software to comply with the specified requirements. Subsequently, so this is just that is once you find a defect, it means the defect is not working as expected to what the requirement is saying the defect should do. So if you were specifically told that the RAM should be 5, if it is 4.999.000, it is wrong. It has to be 5. And that is where we are going to go to our test case design technique, some techniques to be able to test. That will come in alongside when we start the test case design. Now, we go further to say an error that the tester finds is known as defect. The defect is known as fault or bug. So most of the time, we don't really use the word error. We use either defect or bug. I don't use fault. When I see people that use fault, I'll know that, oh, it's kind of old. These are old school. It's mainly defect or bug. When you mean, so they mean literally the same thing. So the last of it all is failure. So failure is the consequences of a defect. So whatever you have been saying previously, the consequences of it from all the if you found the defect, if it's 4.5 instead of 5, it's a defect. So definitely you can't go further with that, with the application. So definitely it's a failure to the system. It's just different ways that we can say failure. When you talk about error, failure, defect. Error, don't forget, is a human mistake. Anybody could do it. Defect, don't forget, inconsistency between expected and actual results. Failure is the consequences of a defect. What is the consequences? So now you have found that expected and actual, they are not the same. There's inconsistency between them. What it leads to is a failure. So in other words, after the creation and execution of a software code, if the system does not perform as expected due to the occurrence of any defect, then it is termed as failure. Not all defects result in failure. Some remain inactive. Please, can you mute, please? So that, yeah. Some remain inactive in the code and we may never notice them. So those are the three things. I'm still going to ask you questions, so I expect you to have known. So keeping software under control, and then what can be tested initially, we said hardware and software. Don't forget, I keep reminding you. So what are the general principles of testing? We've got testing shows the presence of bug. The general principles of testing, they are 7. 7 in number. Testing shows the presence of bug. Exhaustive testing is impossible. Early testing. Defect clustering. The pesticide paradox. Testing is content dependent. Absence of error fallacy. These are the 7 principles of testing. When you're asked what are testing principles, what are general principles of testing? What are general testing principles? Once you hear principles of testing, these are the 7. Testing shows the presence of bugs. Exhaustive testing is impossible. Early testing, defect clustering, pesticide paradox. Testing is context dependent. Absence of error fallacy. So I take it one after the other. Testing shows the presence of defects, not their absence. So testing, once you're testing, you are testing to find a fault. You are not testing not to find a fault. The reason you are testing is to find a fault in whatever software application, whatever you're doing. That's the reason you are testing. So in in a way, we can say that when we're testing, that testing should not show bugs. You can't say that because, as I've said, testing, you want to find the bug. So it is important to remember, however, that what test shows the presence of bugs and not their absence. Thorough testing will give everyone confidence that the software will not fail. Having a comprehensive test strategy that includes thorough test plan, reports, and statistics, along with testing release plan, can all help us with this. So, when you are testing in general, there are phases, there are things that you need to test. For example, you think they will give you blue sky, you want to log on to the blue sky. For you to see that application working, people have worked on that application before it is live. You cannot bring out an application that is not being tested on properly and put it to life. It's impossible. It can't work. There will be lots of failure. There will be discouragement from people. When they even see the name of the application again, they won't even bother to go to the to use the application. And when things are good, you get less information. Is when it is bad, it is publicized everywhere to say, oh, this failed woefully. But when things are good, everybody want the good part. So hence, there are certain processes, procedures that you need to show that yes, you are actually testing to show that to show the presence of defects. You will lay down, there are some documentation to be laid down. That is where test plan, test strategy, you are talking about. Each of these processes need to be obeyed with daily, so that you are sure that you have actually walked through, you have a greater understanding of each of these before you say, yes, this defect does not work. Examples are you've got several test environments that you're going to work on. You will ask me, what is a test environment? A test environment is mainly an environment where this application, for example, you have been given Blue Sky, that you logged into Blue Sky, www.bluesky.com. Sky Citadel. So if you go to that URL, you have logged into the URL. There are things that you start reading from the home page, start looking at it. Before that comes out, the same page that you're seeing, like that live that you're seeing now, you will have it in your test environment. The same application will be your test environment. And that will be an environment where only you, as a tester, or whosoever has an access to to the environment, can access that application. Like now, you all are going to be, you have been divided into several groups. In your own group, you'll be assigned to a project. That project will be seen by only you and your group. In that group that you are in, you are the only one who have access to the test environment. Anyone within your team are the people that have access to the test environment. Likewise, is the same way that it works. So now, let's say let's bring it back to showing the presence of defects. So when you see that there is something that is not right with either the expected and the actual, then you raise it as a defect. Raise it as a bug. It is a failure. You can say that the reason why I had to break down error, defect, failure is because of these principles. They are all intertwined because they work together as one for you to be able to use all these techniques, for you to be able to follow all this technique. They work together. So if all these stages of the strategies, the plan are in place, it is transparent for everyone. The whole team can see it. This is what Yemi is going to test about. This is what um, Yemi found. This is the reason. So everything is already stated in the test plan. Don't worry. You'll be taught how to write a test plan and a comprehensive test strategy. You will design your own yourself and part of your team in this internship. So that's it. So additionally, what is expected is that when you are testing, you keep doing your ongoing monitoring and testing after system have gone on into production is vital. Then thinking further to potential issues that could arise in another good way to help mitigate against any future problem. So this an example is that let's take a mobile application as an example in this context. If you have you are told to test a mobile application. Currently, you have the physical device with you. You all have your phone. So you are told to test on that phone. That is a physical device. If you hold that device, if you are testing, you can think of various scenarios. Maybe what the expectation is that let this device just be able to make a call and I'm able to end the call. That's the expectation of what they want the device to do. So you are able to pick the call, you are able to end the call. But don't forget, while you are talking on the call, another caller can come in. What you want to test again, think aloud, thinking out of the box. Can two callers call? Can we add together? Hence, that's the reason you see all these multiple platforms that come together. You can actually use the two. You're using Microsoft Teams now. You're using Zoom. We all can come into here and watch this. Is the form, the load, because they know now, if you're holding the mobile phone and you're calling just one person, oh, it's just one that can call. We need to add several calls. So this is what is all about you testing to ensure that is defect free. So you take different variation. You are talking about load. All these are part of the things to see. The next one we'll be talking about is exhaustive. Exhaustive testing is impossible. So, as much as you would like to believe that or wish it true, it is absolutely impossible to test everything. I'll give you an example. If you say you were told to test an application, take that application to say, I've tested this application. If you go into that application, there's no defect, there's no error. I've tested everything. I'm telling you that if another person picks that application, is going to find an error, is going to find an issue with whatever application that you have tested. So you can't say predominantly that you can test everything. Even if it's let's take another example of a complex application. You've got several devices, you've got different operating systems. So you were told to test this application. You have maybe hundreds of test cases to execute on that application. It must do this, it must do that. That is where we think about prioritization over test scripts. What does prioritization means? That is the essence of this phase. Prioritization is, what are the test cases that are very, very necessary for me to test first before I go to the minimals? Say you are given application of a car to test. When you want to test the car, the first thing, you need to prioritize your test cases. There are a lot of things to test in the car. Test the on, the light, the wipers, test the engine, test the steering, talk about the wheels, talk about the brakes, talk about a lot. I can count 30 components that we need to test in a car. But when you have those things, because you want to test them properly, you need to be sure, because you might have a tight deadline to meet. So you have to be careful that, let me prioritize my test. Which ones can I test first? Oh, the brake is necessary, because if I don't test that brake properly, if someone should take that car and go out, it could lead to loss of life. It could lead to injury. That's a big one. It's a fine for the company. The loss of life, everything boils down that someone did not test properly. So hence, for you to meet up the 5 days or 4 days or 2 weeks that you were given to test, you need to go with the priority test cases first. Execute them properly, ensure you're happy with it. Then you go to the medium ones. Then you go to the low ones. What are lows? Maybe in terms of, you don't want a blue car, you want a red color. Color is different thing. The low ones is a nice to have. It is not, it doesn't impact too much. But if you have it, it's not bad. But because we don't have time, we don't need it. Let's go for this now, and let's get our MVP out. So let's get our minimum viable product out, so that yes, we are sure that we have something. So at this phase, it's impossible for you to test everything. All combinations of inputs and preconditions, and you could also argue that attempting to do so is not an efficient use of time and budget. That is the reason why you need to prioritize any testing that you're doing. Always prioritize. Whenever you are asked to test, prioritize. Look at the risk area, look at the ones that are necessary first, place them first before you start. So if you can see, however, one of the skills of testing is assessing risk and planning your test around this. That is the main thing. Assess the risk. Break is a risk. It must have a steering. It must have a screen in front, so that nothing, when you're driving, things are not obstructing your view. You must have a good seat belt, airbag, the necessary components. So you start arranging them like that to ensure that, yes, they are in line with what the expectation is. Please do not forget, if you have any question, pop them in the chat. So that's it about exhaustive testing. So early testing. Why I said this, I said early testing saves time and money. That's just like a quote. Early testing, it saves time and money. So when you test early in a life cycle, when you are testing frequently, when you start testing, like for instance, you have a requirement, you've tested the requirement in terms of static testing of the requirement. You have checked, do I as a tester understand the requirement? Yes, I do. Is this requirement ambiguous? BA, can you break it down? What do you mean by this? Oh, is this are not specific here. Do you need anything specific? Can you add it into your requirement? All these questions could be asked when you're doing your static testing. It is a stage. It is a phase. And once you start testing early, it is easier to fix a bug when it's in early stage, before the code is even deployed. It is easier. The resources, time, money, it's easier to be confined than when you have finished the application, you now found the bug at the user site. You are still, so it means when you found the bug at the end, the target system, it is more difficult and costlier because we have to start back from the basis. Requirement, do you understand it? Yes, maybe we didn't break it down properly. All this should have been checks that should have been done. That's why when you have a user story, make sure you have a clear understanding of the user story. You ask your questions at that point. Tell them this user story you have created here. Do you have an acceptance criteria for it? Oh, you said it should show 5 pages. Why? What are going to be in those 5 pages? In page 1, what are you expecting to see? What do you expect to see in page 2? Should it be in sequence? Okay, if those pages are hit, how does it link to each other? All this, you need to know how the integration is, how you're going to navigate from page 1 to 2. So when you ask those questions earlier, it gives you a better view. And as you're asking the question, it gives you an insight to the project. It gives you more understanding on how to design your own test cases. So advocating for early testing is the key. And you in the internship, that's why you're here, because it's more of agile testing. So you are going to be testing early. Your testing is going to be done early at every phase. So look, so it involves testing early. It's also fundamental agile principles, which sees testing as an activity throughout rather than a phase. So you should be testing right from the beginning to the end of this of yours or of the application. So testing is ongoing. That's why it's agile. So as you're seeing things, you're fixing, we are testing, we are retesting, we are doing regression. All these are processes that goes with early testing. So the next one we'll be talking about is defect clustering together. So defect clustering. So the defects, they cluster together. So at this phase, you ask that what does defect clustering mean? This is an idea that certain components or modules of software usually contain most numbers of issues or responsible for most operational failures. So, like the way I do my reporting is I do a defect density to be able to validate where exactly the defects are clustering when you are doing your reports. For example, you've done an execution for today. Maybe 5 of the defects failed at initial stage of launching the application. So you will know that 10 of the defects failed while you are trying to assess the test environment. So you will know that your defect is more clustered in where the environment is. That is where you are getting most defect, most issue at that time that you're testing. Then the other parts, you could do it in a pictorial way, you could do it in a graphical way, you can do it in a pie chart. So there are a lot of ways that you can actually bring to light of how the defects, the way you do your report in terms of where it's being tested. So defects could be at that phase, it could be in the environment. It could be while you are trying to log in. Maybe you've attempted logging like 4 or 5 times. It could be a yardstick. So wherever you are finding most defect, you need to state it. That is where you will find out that, oh, this is exactly what is happening here. Maybe you've tried to log in like access the test environment like almost 10 times in that cycle, but maybe at the 11th time, of course, maybe it worked. And you try it again to access it, you find out the same issue. So you need to assign a proportion to it to know that 80 or 50, 60% of the defects are clustered in the environment. 30% of them are while launching the browser. 10% is on the search functionality. So we now know that the defects have been broken down into different places. So we know the first cluster is the environment. The next cluster is the launching of the application, which goes to the next one, which is in the search functionality and others. That is the way you proportion the, so it's more of the defect data for you to know more about it. So that's the way defect clustering is. Testing, therefore, should be focused on this area. So if you know it's in the environment, you test properly in those environments. So ensure that, yes, you're looking at the defect density, looking at the areas, testing it properly, look at different variations to be able to test it. So after then, pesticide paradox. Beware of pesticide paradox. So the reason why this theory came about is that this is based on the theory that when you use pesticide repeatedly on crops, insects will eventually build their immunity, render it ineffective. So, like now, you are spraying your crops, insect, and all the time, they will get used to it. Their immunity will be built around it. So, when next, after some time, they'll be used to it. They won't feel the impact again. That's the theory that is linked to this pesticide paradox. So let's bring it to testing world. So similarly with testing, if the same tests are run continuously, then while they might confirm that the software is working, eventually they will fail to find new issues. It's just like now, if you keep using maybe the only thing you're testing, you've been going through the login, just go through the login with the happy part, just be testing. You know that this one works. That's the only thing you're testing with. The same test is what you're running for it. I've been able to log in just with one scenario. By the time you try another scenario, it might crash. You might find new issues. You might find a lot of bugs coming in. So it doesn't mean that because the happy part is fine, there is no negative part. Hence, the theory of positive and negative testing. So you must check the happy part is fine. You must check with other negative scenarios. Now, if you've tested with this variation, you also need to change your cases to suit it. Like you can't tell me that you've got 3 test cases that you know you execute all the time and is this. After a while, I find anything again 3 test cases because I know I know the results. So what you want to do is let's change these test cases again. Let me update it. Let's see if it's going to work. That's the way you have to. In test case, when you're writing your test case, we modify, we update all the time. We amend our test cases to suit the test that we are actually testing. So it is important to keep reviewing your test and modifying or adding to your scenarios to help prevent the pesticide paradox from occurring. Maybe using varying method of testing techniques, methods and approaches in parallel. We are going to talk about the techniques, different techniques that we are going to use to actually write our test cases. So beware of pesticide paradox. Anytime you remember pesticide paradox, remember when you are trying to repeatedly use pesticide on crops or insect, that it will build up an immunity, and it won't have any effect on them. It will be rendering it ineffective. So the same thing goes with testing. If you keep testing with just a particular scenario, it will be good, but it doesn't tell you whether the software is good or not. So the next one is testing is context dependent. So is all about context. The methods and types of testing carried out can completely depend on the context of the software or system. For example, if you're going to do an e-commerce website, there are various types of testing approach. If you're going to do an API testing, there are different things. So there are various ways of testing. They are context dependent. So let's take an example of Blue Sky while you were filling your form, when you were registering, or Happy Path, you are just going in from the front. There's someone at the back. There was an application done at the back. There is a reporting system. There's a database that checks all this. So it's going to go into the database. There are testing being done. So all these are different. They all depend on the context that we actually put into testing. So the last of it all is absence of error is a fallacy. If your software or system is unusable or does not fulfill users' wish, then it does not matter how many defects are found and fixed, it's still unusable. So if the system is not friendly, if people cannot use it, even if you have found 1,000 errors, it's been fixed, it's looking good. If it's still not usable, then it's not usable. So when you are given things to, make sure is in accordance to the requirements. I keep emphasizing on you going back to that, because you need to validate, you need to be sure that, is this the right product that we are working towards? And that gives you an edge to know that, are we doing the right thing? That's where it is. So it doesn't matter. So in this sense, it is irrelevant how or error-free your system is. If the usability is so poor that people cannot use it, if you cannot use the system. Like me, I prefer, when you give me an application, I like it to be user-friendly. Now you can ask me, what is my own, what do I mean user-friendly? I like so simple system, not too much to do. Don't give me an epistle for me to go. No, give me something that is easy. I can navigate, it's kind of easy, is well understandable. Anybody can use it, because you need to know your target audience. You need to know the people that are going to use the application. You need to know people. So if you're not meeting the right specification, you are going to lose out of it. So if it's not useful, it's not useful. It doesn't mean that because the whole system, there's no error in it, then you believe that is good. No. Once it's not useful, it's not useful. That is the reason why they said absence of error is a fallacy. So meaning that, even don't think because this system does not have an error, then it's working as expected. No. Is that what the user wants? Is it usable? Is it friendly? This. So those things have to be put into consideration. Don't forget. So these are the things that we ensure we go into. So it is important for us to note all these general principles. They are 7 in number. Testing shows the presence of bug. Exhaustive testing is impossible. Early testing, defect clustering, pesticide paradox. The testing is contents dependent. And the last of it is absence of error fallacy. 7. 7. I keep reminding you your trait. I just want you to keep remembering that you as a tester, you need these things. If you have it in you, then you are great. You're good to go. So we are talking about creative mind. We are talking about keeping keen observer, time manager. You are talking about you have got listening ears, which I know a lot of you, because I'm going to ask you questions tonight. So believe so I know you're optimistic. Your mind is kind of presence. So you've got the skill, you've got the trait, all those traits. If you've got 2, 3 of it in it, man, you're there. Most of us, we can manage our time out of your 24 hours, so you know what exactly you're going to do. So this is quality of a good tester. Again, I bring it back to you. That is, I always want to remind you what it is about you as a software tester. Make sure you are putting all this in place. Ensure you are thinking out of the box. Let your mind, if they give you a requirement to focus on, think outside it. How do you think outside it? I've been given a requirement. Research, ask question. When you are asking question, think that this, let's try this other scenario. Think it, put it down, try it. You can find other bugs even before, without developers knowing that there's going to be an issue. So that's the way you are. So that's the quality of a good tester. Remember, verbal communication, written, that's what we've been doing. And better part of it, we are going to fundamental test process. So this is the big part of it for tonight. And I'm going to dwell more about it. So as I said, that this is a fundamental test process. We've got 5 of them. So remember, general testing principle, 7. That's testing principle is 7. Test planning, fundamental test process is 5. And these 5 are 2 words. They come in 2. Just the last one is 1. So the first one I'll be discussing about is test planning and control. Test planning and control. Test planning, it involves producing a document that describes an overall approach and test objectives. It involves reviewing the test basis, identifying test conditions based on analysis of test items, writing test cases, and designing the test environment. That is what is all about test planning. So let me take it to another phase of it. We want to prepare a delicious meal, and you need to demo the meal to people. You want to sell a meal to people. So the first thing you want to do is that we need to plan. What kind of meal do we want to do? We want to cook white rice and stew. That is the meal we want to cook. So that's my test plan. I start designing my test plan. What are the things I start designing? I start looking at what are the things that I'm going to use. Of course, I need my rice, I need my plum, I need some pepper, scotch bonnet. It depends on how spicy you want it. I need some ingredient. I need this. I list all that into a document to be able to give people my prototype that this is what I want to cook. This is what I want you to come and see when I'm cooking. This is what I'm going to demo to you. That is my planning phase. I've not started anything yet, but I'm just telling you that I want to cook white rice and stew. This is what I want to put in the white rice and stew. This is how I'm going to cook it. I've just bring out the ingredients. Now, let's bring it back to what I have said initially about test planning. I said it involves providing, producing a document that describes an overall approach and test objectives. So now we are going to give you an over the test plan document, that's which comprises of the test strategy, test plan. So all these documents are the initial phase of it. So when I give you all those the test approach and also the test objective, it involves us reviewing the test basis, identifying the test conditions. I've told you that it's rice, but all my conditions, these are the things I need. I need white, I need rice, raw rice. I need plum. I need scotch bonnet, which is I want it spicy. I need some ingredient. I need some salt. I need water to be able to boil the white and do other things. I need some protein. So any type of protein you want to put, you state the protein there. That is my planning state. So what is the purpose of me planning? Why do I need to plan? I want to cook white rice and stew. If I don't plan down, I can't just bring you into a demo to say, okay, what do you think I should cook? No, I am the one. I've been given a prototype to say, give us something. This is what I want to do. This is what is expected of me. So the purpose of this is to determine the scope and risk and identify the objectives of testing. That is the reason why we need to plan. To determine the required test resources, like the people, like the test environment, a lot of things. The other purpose is to schedule test analysis and design, which is the next phase. Because before, for me, for these 5 processes, you can't jump anyone. You have to start from here. And that is it. It's just like me. I want to cook white rice and stuff. I can't just go to this number 5 and say, I've finished cooking. What have I cooked? I didn't bring anything out. I didn't even boil water. So I've not started cooking. So I can't go to number 5. I have to start from the prep, from the foundation of it. So that's it. Then the control part. The control. I've talked about test planning. I told you these are 2 words. Test planning. Now control. So the test control part of it is that this is the activity of comparing the actual progress against the plan and reporting the status, including every deviations from the plan. So, for example, I want to cook white rice. Oh, I don't have enough sauce to cook the white rice. I've written my test plan. I've given you all the ingredients I've mentioned. But if I'm going to deviate, that I'm not going to cook white rice again, now I'm going to make fried rice or I'm going to make jollof rice. I need to put that into the team to let them know the reason why I am deviating from it. So it involves taking actions necessary to meet the mission and objectives of the plan. the project. So maybe now I've been told that the white rice you want to cook, so that we won't have longer time. Why not let's make it to jollof rice, something to combine and give us. I'll say, okay, that's fine. I can manage whatever I have now. I'll use the same ingredients. I just need puree to add to it to make the jollof rice. That is me still doing my prep. I've not started cooking at all. That's the foundation. So that's your test planning and control. Now, while I am planning, the reason why I need to plan is for me to be able to know what I'm going to do when it's time for me to analyze and design. So now let's take another step to number 2. Don't forget planning and control. So test planning, you understand the way test planning is, which involves you producing documents when it comes to that phase. Now, we take it again to test analysis and design. What is test analysis and design? Test analysis and design, they have this following. I will review the test basis, check the information, take white rice as one of my tool. That's my test condition. I start analyzing with my test condition. So from there, I use it, bring it to the testing world. I take my requirement. What's in my requirement? Logging functionality. I'll take in logging as one of the feature. I'll start analyzing. What are the scenarios I want to write on logging? What are the test bases? Okay, the logging. My happy part, I'll use the valid scenario. My negative part, I'll use invalid of these variations. And I'll write every variance of what I'm going to do. That's where I'm taking up to my analysis to say, oh, this is what I'm going to do. That's the next phase I'm going to take. Then immediately I'm doing that, I'm also analyzing to see that, okay, test cases, as I'm doing it, how many is it going now? Okay, we have looked at the requirement. Yemi have picked logging, so I've analyzed. She has written 10 test cases for logging. We are seated there. So I've done the analysis, I've designed it. Analysis, my logging is it. I've designed it, I've written my test step. Logging using this valid scenario, logging we using invalid scenario. Those are my design. So I have done it. So once I finish the design, then it takes me further to another place. Then while you are doing the design in that place, it will tell you, the next phase I need to do is my implementation and execution, which takes me to the third place. Don't forget, what I have just done is that in the test plan, I put the first one, I put all my ingredients down. In the second part, I've put my rice. I'm going to boil my rice. I'm going to cook my stew. That's my second part, and this is the way I'm going to do it. So, boiling of rice, pour water, put rice in the pot, and do this. Those are the things. The stew, peel the pot, and that's another one. So that's it. So now, how do I start implementing it? So, implementation and execution. Text execution involves actually running the specified test on a computer system, either manually or by using automated test tools. It is a fundamental test process in which actual work is done. So at this phase, test implementation and execution is actually the actual work. So now your actual and expected is what works here. My expected and my actual needs to be valid here. So now pick the rice, boil the rice. I need to start boiling the rice, put it in the pot, start doing the actual process that I have stated. Put the water in the pot, put the rice, start boiling it. Then take another pot, put the stew inside, put the plum, put my oil, put everything, put the ingredients, start doing it. I'm implementing, likewise, I am executing it. Implementation is I have taken the rice, I've poured it in the pot where the water is. That is me implementing it. Executing it is now that it is boiling, it is cooking. That phase. So that rice is done at that side. Same thing with the stew. I've blended the pepper, I've poured it in the pot, I've taken it. That is another phase. So bring it back literally to develop and prioritize test cases. So let me just take that as a test implementation as the major tasks. These are the major tasks of a test implementation: to develop and prioritize test cases by using test technique and create test data for those tests. So let's go back to our general principles of testing. You can now see why I tell you that I had to bring you back to error, defect, failure, general testing principle, fundamentals of testing. All these are brothers and sisters. They are repeated things. They work hand in hand to make things work. So we rely on ourselves to make those things work. These are the processes to make this fundamental test process work. So at that implementation, so what we need to do here is we have talked about how to prioritize in some of our general principles of testing. So we need prioritization here. We need to start looking which one do we want to cook first. Of course, everybody wants to. We want to eat. Let's start cooking the rice first. After we cook the rice, we cook the stew. So now your test cases, which ones are the priority? Is it the break? You put the break first. You arrange them in accordance to what the specification, the requirement, what you see as the risk. So assessing the risk at this point is kind of key and vital in this third process. These two guys, the implementation and execution guy, are key. So at the next phase, let me bring it back again to testing world to create test suite for the test cases for effective test execution. So as you are implementing it now, I'm also the test cases I've created is what I am doing. I am implementing it and I'm executing it so that everything will come as one. Then to recreate, to re-execute the test that previously failed in order to confirm is fixed. That is it. So at this phase, you can see that these three guys, they are key. They are all key because you've started your planning, you have analyzed, you've designed, you've implemented, you've executed. Now, all this have been done prior to what you've been given in the requirement document. Now, we have to go to this person. How are you going to relate it to the business? Nobody knows what you're doing all the while. There are preps that you need to now follow to let them know that this is what I have been doing. At this phase, you will look at different things while you're doing it. So let's go to the evaluating exit criteria. What does this mean? Exit, stop. We have finished number 1, 2, 3. It is transparent. You all have been seeing what we've been doing. Now we have to stop testing. At this phase, what have we achieved? What has been tested? 80% of the tests have passed. 10 is not run. The other 10 is blocked. And they'll be moved to next release. You do your analysis, you do your reporting, make it crystal clear. Now, you as a tester, with your experience, are you happy with the application? Is user friendly from your perspective? Does it meet what exactly the client wants? At this phase, while some of the time when you're doing implementation, we've done this execution. Before you want to create an exit criteria, means stopping, which means we have gone from one environment to test environment. From test environment, it's begun to maybe to a UAT environment, user acceptance testing, where we get feedbacks. We have caught some users, they've played, they've also done work on this implementation session. We are all happy. Let's happy part, everyone is happy. Now give us this. That's when you stop. We now evaluate the exit criteria. We've got a specific window. What is a window? Is how you are meant to test your first, maybe test environment. This application will be there for 2 weeks. So your deadline is within 2 weeks. Once it's done, we'll move whatever has been done in test environment to UAT. UAT, you've got 3 weeks to play with. We start testing in UAT. Once UAT is fine, there's another environment, pre-prod. What is pre-prod? Pre-prod is more of a mirror of what is going to live environment, what is going to for everybody to see. So is pre-prod. So that's pre-production environment. So prod is production environment, life environment. So in a pre-prod environment is a mirror of what is going to be in life. When I mean mirror, if you look at the mirror, you see your replica. So there's nothing in the mirror. You can't start scribbling to start. No, it's what you have in the mirror that is going to be there. What you have in the physical is what is going to be in the mirror. So the same thing, your pre-prod is just the mirror of what is in production, what is going to production. So that's it. So in exit criteria, it is predominantly there that at this phase, what do we have bugs that are left? Are there safe tools? Are there critical bugs? All those analyses go when it comes to exit criteria. So now we have stopped testing. We need to give a report. That's what for. Once this phase is done, then we go to the final part. In this final part, this is test closure activity. Test closure activity are done when software is ready to be delivered. So now I've finished cooking the stew. I've the rice is boiled. I've tasted, everything looks good. I've stopped cooking. Now I need to give a closure report of what I have cooked. I dish the white rice bowl in a good plate. I garnish it with whatever I've got and I place it out to say, this is what I am presenting to you. Hence, that is my closure activity for the food demo I was doing. Now bring it back to our software testing world. Test closure activity are done when the software is ready to be delivered. We have finished testing, actual expected result, exit criteria and reporting are all in state. Everyone has a view of how testing has been done right from the beginning to the fourth point. Now they need a rubber stamp to say, we have finished testing. You need to give them that report. Then the testing can be closed for the other reasons, like what a project is. When a project is cancelled, when some target is achieved, when maintenance release or updates is done. All the phases I've served you in a plate, I've put it there for you. Now, I can say this is my test closure report. I've done all the testing, all the defects are there. I've all the triage, defects have been fixed. These are the ones that we are left with. They are low bugs. Is a nice to have. They can be fixing that later. That is it. You have done the analysis. everything is in your closure report and you state it out. That is when you can say predominantly you are finished. So test closure activity have the following major tasks. So one is that you to check which plan deliverables are actually delivered, as to ensure that all incident reports have been resolved. Hence, while we are designing, while we are analyzing, when we were doing our implementation, I told you that we were looking at the requirements, we were writing it. At that phase, you are doing more of a traceability matrix, mapping back to the requirements that this is what has been delivered. From your test cases, you can analyze from the requirement to say, these are the things that have been delivered, this is what has been tested from our end, this is what you have been given, and that is it. To finalize and archive testware such as scripts, test environment, for example. So all this, you have to ensure that you have all your test environment, all the test scripts, available documents, test plan, everything, all your test documentation must be in a proper location where it's accessible for everybody. I'll tell you the reason. Anyone can go in there to check. You will think people don't look at it. They do. Some people go there to look, a lot of people, and that's where they know where you're. Just for you to, in fact, if people don't look at it, you could come back if anything happens to the test to say, did you test here? Yes, I did. Where is your proof? You give them your proof. Then to hand over the application to the maintenance organization, they will need to give the support to it. So that's it about the fundamental test process. You see, I brought everything from the beginning just for you to have a clearer view how everything links and sync together. This is the major part of we as testers, what we need to do. All this will make more sense more and more when we have the test case design, when we have the other sessions. You will see everything come to limelight. That is it from this session. And I would say thank you all for this. And let's go to Q&A session. And let me go to the question and answer. Please, if you have got any question, pop it in the chat, please. Any question, please pop it in the chat.
The chat is disabled.
The chat is disabled.
Okay. So if you've got, yeah, you can raise your hand. I can come to you. Okay. I think Derry or Deniro, you're raising your hand.
Yeah, thank you very much. Actually, I was going to raise the question earlier when you started. The voice was fluctuating, so I wasn't sure if it's for me or it was general. So I was going to raise that, but I couldn't put on a general chat because it was disabled. So it's no longer useful.
It was general, I think.
Oh, so sorry, but did you not hear me later?
We were hearing, I could hear you, but we are missing some keywords.
Okay, so let me go back to when you mean the first part. So let me go back to my screen. So you mean, can you hear me clearly now?
We can hear you, yeah.
Okay, so your first part, I will believe the first part is the very first one. Am I correct?
It's all right now. It's all right now. I think it's over. But I was just going to raise it. I just to let you aware what was happening. So that's why I raised
Oh, okay.
it.
Oh, so sorry. I didn't
It's all
even.
right.
Yeah, so sorry about that. Yeah. So, um, let me just go down. If you got any question, please just unmute yourself and ask me. Let's go to Sheung Rotiba.
Good evening. Good evening, ma'am. Can you
Good
hear me?
evening. Yeah, I can hear you clearly, please.
First and foremost, thank you for the lectures. I want to take my question from the place, from the point where you said exhaustive testing is impossible.
Okay.
Yeah, so I noted a point where you said we have to prioritize what we want to test. And so
Right.
my question will come in this manner: in the process whereby we're trying to test a product, and we try to prioritize what we want to test, either because of time or because we're trying to manage resources, which is money, or because maybe the product owner is trying to make us deliver on time. Is it not possible to also omit some things that we feel are not necessary that might be very important to that product? For instance, let me use a car. A car has, like you used before, a car has many components, and even like I don't know, an adapter in the car can make the car not to work. So we just say, oh, it's an adapter, it should be working, but the brake, because it's essential, let's look at that. The oil, but the adapter, let's prioritize and let's leave that. Is it possible we also omit some things that are that might not look very how will I put it, that might not be crucial or critical, but might also have an impact on the product? Thank you.
Yeah. Very good one, Sean. Yeah. So from this point, let me take it from here. So when I mean prioritizing, there's something you're prioritizing again. There's something you're looking towards. Don't forget, you have a requirement. You have a requirement, and that is the way you're going to work. So when you are prioritizing, when you have done your test cases, you look against what is in the requirement. When you go back to requirements, have I written the script? Is this what is meant to do? Now, that will determine the kind of test that you are going to put first. Let's take the brake. You said there are many things in the car that we need to prioritize. I totally agree with you. But there are some that needs to be more, that is more than the other. You have taken an adapter. With the adapter, if, like, let's say a plug in the car is removed, when you start the car, I'm so certain the car might not move. So that is a fail for you. So we know that that has to be fixed. Now, the reason we're saying there are some components, the reason why we say prioritizing is that there are some critical ones that are needed to be put in place. Those critical ones are the ones that, you know, when we were talking about consequences of not testing properly, there are several consequences. It could lead to loss of life or injury. It could lead to loss of business reputation. All these are what are in place. So if now you have said you didn't test, you have taken a break, instead of, if they tell you to test out of a break or the plug that is there, you will choose to test the brake plus, because the thing with the brake is that if you are driving, the car might move. Every component must have worked in the car. If the brake is not properly tested and is not good enough, I can totally tell you that it could lead to loss of life. That is key. So from your question, I won't want to say that you will miss something. No. You have to know exact tests that you need to prioritize. Reason for prioritization is to look at the risk, the quality before you move. So if you feel the adapt that plug is kind of key or vital than the brake, put it first. So you need to be certain to be sure that this, and what gives you an expectation for you to know what exactly is going to be prioritized. You can look through from the requirements. They will tell you there are from the requirements, it is stated there, must have, should have, needs to have. Those are key things. So even before you pick that break, the business analysts have already written it that it is a must. It must work. So all your must have must be tested. They should be your priority. Do you get me? They should have, should be the next priority. A nice to have, you can have it. So it's not you now that is stating it. It is the requirement. It is the decision that people have made from the requirement that gives you that. So yeah. Is that fine from your side, Shell? So let me see who else is.
Yes, thank you very much.
You're welcome. So who else? Let me see. I don't know why the chat is not enabled. Any other person with question? You can unmute and ask me.
Hello, please. Hello.
Explain, please. Olamide here. Good evening.
Yeah, good evening. Thank you so much. I really appreciate for the lecture. I just want to ask, what format will the internship take? I understand from previous meeting that we will stop using Zoom with time, and I thought we are going to use Teams tonight. So I've been on Teams, and I wasn't sure if I was at the right channel. So I was there for about 40 minutes. No, not sure. Yes, I didn't know I'm to come to Zoom. So I missed the major part of the lecture actually. So,
okay.
you know,
So
there was this
sorry
confusion.
about that. So sorry about that.
My question is, do we have the link to rewatch this?
Okay,
again?
So let me take it from the first one. The first one is at each of the QA group, even the general training group, the internship, your link to each of these to the class will be stated there for every evening. It will give you a reminder. I'm so certain 15 minutes before the time, even when the class starts, there's always a reminder there to say join through this link, and that link will be there. So you would see that if it's going to be a Zoom class, you would have seen in the Zoom link, you can just click and state from that Zoom link. That's the way it's done. So, but sorry about today, you can still rewatch it. So for this class, you can rewatch. Immediately we finish now, you'll find the video on and you'll be sent the link to rewatch it.
It's live, man.
It's live.
It's live. It's live on YouTube right now.
Oh, fantastic. So it's live now. So the thing you could do is that you can rewatch it. Thank you, Fola. So you can rewatch it on YouTube, and any question you have, please always feel free to ask any question at any time. While you're in the class, you are free to ask any question. That's the essence of internship. We need to help you, to correct you, anything you have. We have this lecture have been broken down into various phases. At the end of this lecture, I'm going to, the way you're going to do your script, by the time we give you all this training, you can even start looking for a job immediately. So hence, that's the reason I'm taking my time, bringing it out of testing world, bringing it into it. So that's the way this works. So Olamide, for your two questions, always check the Telegram for the update before the time. As you were standing there for 40 minutes, you could just check Telegram at any time. And I would also, I'm so certain as I'm looking at it now on Telegram, it was there. So if you are going to use Teams, it will be communicated to you. Any avenue or any mode that we're going to use, it to be communicated to you. Then the video is live. Thank you.
Then the other question is, I received another link that took me to another Telegram page for QA. When are we going to move to that particular page?
Okay.
Is it going to be a general group or for QA alone? I wasn't sure. I just clicked on the link and I found myself in another page, Telegram page. So it
Yes,
wasn't
so
really clear.
okay, so now we've got several teams in the internship. We've got the Scrum Master, you've got business analyst, we've got us as a QA. So we are going to have a QA guild, just like a community within the internship, where it's going to be more of QA. So if you have any issues, we pop it into that general team. We've got bodies, we've got mentors there that will pick up the question and start working on any question and popping in the answers as you have immediately. So that link must have led you to the QA link. And
Telegram.
also there, it will be sharing all the links to various lectures, videos, and things of previous one.
Okay. Thank you.
Yes. So, okay.
Hello,
But
good evening.
good evening. Yeah, I can hear you.
Good evening. Thank you for the presentation. So brilliant. Thank you very much.
Thank you so much.
Please, you mentioned under defects clustered together.
Mhm.
You mentioned something about 80% of defects are due to 20% of code. I'm a bit confused there. I don't know what.
So,
Thank you.
thank you, Bola. So what I mean there is, most of the time, if you find a defect, the defect is not going to be, is going to go and be fixed in the code before it comes out. So the defect you're finding is more of the fault of where the code is coming from. Don't forget, you didn't just start testing the application. It was built on a code base. So it's the code that is going to bring out the blue sky page that you're seeing. So there are code that have been developed that has been integrated together to form that page, this application that you're using. Hence, any defect you find there tends to relate back to the code. That's the reason that I gave that analysis. So most of the time, when you find a defect, it will be related back to the developer. The developer goes back into the code, analyze and find that defect where exactly, because every phase, everything you're seeing on your application is being coded. So your URL, your endpoint, the login, there's a code functionality, the code set for that login functionality. So we need to know each of the developer knows, oh, she found the error in code. That's fine. He will go, he found the error in login. He will go directly to the login and see the issue and fix it and redeploy. So that's the way it is.
Okay, thank you very much.
Yeah, okay.
Hello, good evening.
Good evening, please. Yeah.
Thank you for the beautiful presentation.
Yeah.
I was just about to ask the last question that you just answered. You said 80% of defects are due to 20% of the code. If 20% are from the code, where does the rest of the defect comes from, please?
So defects are, for defect clustering, there are different places that defect could be. Defect could be in the test environment. Defect could be in the login functionality. Defect could be in maybe the user details you're using. So it depends exactly where the defect is coming from. So the essence of defect clustering is for us to be able to manage where exactly we are having this issue consistently. If consistently we are unable to access or launch the application, then there is a defect clustering at that login, at the application launching. Hence, I will give it back to the developer to say, if I'm seeing this session being broken at all the time, there's a way for us to keep an eye on that particular component to say, this side, I am finding most of the defect. Now, this also helps the developers and also helps the whole team at large to know that it's not that they've gone into the application so much, they've not tested much. They're still having defects around the environment. They're still having defects around the login. They're still having defects around the set functionality. Hence, the reason for that. So mainly, we are talking about the defect density. Where exactly is it heavy on when I started using the application? The irony, the thing about this is that when application is built, you're not expecting a full for the application to be as much or good as expected, because it's a new application. There are still mistakes. This is a greenfield. We are starting afresh. So there are a lot of things that will be coming up that we need to test, and we'll be pulling back. So hence, that's the reason that we initial phase, we tend to look at the where exactly we are having issues. That's what we are trying to explain when it comes to defect clustering. It's not that the defect will not be fixed, but I need to, when I'm relating to people that are not in testing world, the people that are business oriented, are the business clients. We are talking about our stakeholders. They don't want to know that login functionality is not working. It's not their own. They don't want to know that this. They just want to have it in more of a graph to say, okay, the defect here that we are having for today is due to the environment. That is where. So most of our bugs that we have raised today, we have raised 25 or 50 bugs. 30 of them falls to environment, falls to we not being able to access the application, falls to the seat, to UAT or seat environment not working as expected. That is the reason for the defect clustering. Mainly, I put this is just more about you putting it in your report to show when you start to say, oh, this is how I'm testing, this is what has been achieved, this is where it's failing more, that is where it is about. Okay, Lala, is it clear about it now?
Yes, please. Thank you very much. Thank you for that.
That's right. Any other question, please?
Good evening. Hello, good evening.
Good evening. Yes, please.
Yeah, sorry, my question is that while you are testing and maybe you are running out of time or budget, who determine the test cases to prioritize?
You as a tester, you have to. That's why before, if you're given a window to test, the first thing you need to think, and that's the reason why it's not just for you to start testing. No. As a good tester, you would have prioritized your test scripts. When you are doing your test, you would have prioritized your test cases. Let me give you people a clearer understanding of some things. When you are building your test script, don't think you will see the application. You don't have any application. Even if you is either you have an application or you don't have an application. What I mean is that your requirement is a rule book for you to build your test scripts on. And that's why in the requirement, when you are reviewing the requirement, you must ask them a proper business requirement, a proper requirement to state that this is mandatory. This is a must-have. It will be stated in the, is one of the status that is going to be in your requirement document. If it's not there, ask the question. You want this login, is it a must? We must have it. If it is, can you please state the ones that are must have, the ones that I should and that will help you to be able to prioritize your test script. If they ask you that, why do you need it? This is for me to be able to prioritize my test scripts. Once you say that, they know you know what you are doing. So you as a tester, it's on you to learn how to prioritize your test cases. How do you prioritize? Is you looking at your requirement document, validating it against to be sure that these ones are the necessary ones that they need for them to be, they are the necessary ones that needs to be prioritized. Understood?
Yes, thank you.
Correct. Any other question before we end the class for today? Any other question? So before we go further, before I finish, because I don't, now the chat is not working. If not, I would have loved it to work. But so so now everyone have asked their question. It's now left for me to ask my own question. So my first question will be, who can tell me how many test principles do we have?
We have 7.
Correct, Abolaji. Fantastic. Can you name some?
Sorry, we have the exhausting testing.
Correct, Dora. Well done.
We have early testing.
That's fine. Don't say any other one again. Next person should take. Well done.
Clustering.
Defective
clustering.
Fantastic.
Pesticide paradox.
That's fine. Don't say any other one again. Next person should take it.
Error fallacy. Testing in context dependent.
Fantastic. Well done. You
Absence of error is fallacy.
Fantastic. So the next one is how many fundamental test process do we have?
We have 5.
5.
Yeah. Don't worry, everybody that is talking. If you're not saying things, I won't give you things because I've got different knowledge to give this night. So because I'll call your name. If you don't talk, I would know. It's because I can't see it on the chat. If not, so I'll call you. I will know if you're not talking. So out of the 5, can you mention the 5? If you mention one, don't say it again. First person, Mokbelola, don't say anything.
Okay.
Test planning and control.
Fantastic. Next person, don't say any other thing. Next person.
Test analysis and design.
Fantastic.
Test analysis and design.
Yes.
Test implementation and execution.
No. You said one. Olu, you said one.
We have
the next person.
Exit criteria.
Test closure activity.
Test closure activity. Fantastic.
Evaluating exit criteria and reporting.
Fantastic. Test
implementation and evaluation.
Execution. Fantastic. So which one do we which out of the 5, which one do we start? Which one is the third one?
Test implementation and execution.
Implementation and execution.
Fantastic. So which one is the 5th one?
Test closure.
And activity.
Fantastic. So I'm seeing a lot of people answering. So now let's go. The last question of tonight will be, what is error?
Error is a mistake that leads to a defeat, which can result in a failure.
Fantastic. So Dora, mute. I don't want to. You cannot talk again. You cannot talk again.
All right.
Just if you want to talk, just say me. Start with me, because I want to see names that have not spoken, so I will not answer. So now, what is error itself? Error. Someone should say, when you,
Error is
Error
a
is a
mistake.
mistake.
Normally,
Error is a mistake.
it's a mistake that normally caused by human,
Human.
and so it does lead to a defect. Why defects leads to a failure in testing system.
okay, I agree. So give me examples of error. Who are the people that can make error?
Like a
Business analyst.
business analyst or architecture. Those are people that can make error.
Anyone, fantastic.
Yeah. Anyone.
Or users
Anyone
themselves.
can make
anyone. That means all.
Fantastic. Yes. So now, what is a defect? What is a defect?
It's
Yes.
inconsistency between expected and actual result.
Correct. Correct. What other name can it build?
Bug.
Good. Well, now I can see you all were listening. Then the final one is failure. What is failure?
Failure, it is the consequence of
effects.
Dora, I said if you
She said answer me first.
So Olamide, I'm not going to, you've been talking. So I'm going to call someone myself. Someone I know has not talked. I think there is Nathaniel Akinyemi. I've not heard you people. Emmanuel. So I need to hear some more. So who are the Anna? Anyone that wants to help out of all of you? Failure. Emmanuel.
A failure
Anna?
is a consequence of a defect.
Correct. Correct. So for tonight's class, that's where we end. I'll just implore you all to please go back, watch the video. Any question you have, you're free to ask on the group chats. You're also free to ask any one of us. We are ready to help you at all the time. The next class will be on Friday, and I hope to see you all then. It's going to be a very, very vital one on Friday. Please make sure all these things, you are learning them and keeping them as part of your memory. You won't forget it because all these things will work hand in hand. I wish you all the best for the night. And for those of us in the UK that is quite old, I mean, it's quite cold. Please wrap yourself up very well and have a wonderful evening.
Hello. Do you mean the next lecture will be on Friday, do you mean?
Hopefully, I think so.
Okay, not tomorrow.
Excuse me, please.
Yes, please.
Do you mean tomorrow is free?
No, for testing. I think the next lecture should be on Friday. It'll be communicated, but I think it should be onDay.
We have a timetable. We have a timetable.
There's a timetable on the.
There's a timetable on Instagram, on Telegram.
On Telegram.
There's no lecture tomorrow. Thursday.
There's a lecture tomorrow.
No.
There's no lecture tomorrow.
There's a lecture tomorrow. There's a lecture tomorrow. Go and check the timetable.
Okay. If there's a lecture, you meet me here.
For QA, there's no lecture tomorrow. Go and check very well. QA, there's no lecture tomorrow.
There's no lecture tomorrow.
Make sure you're looking at it.
Testing. It's on Friday, SDLC and STL. Tomorrow is Friday. Yeah.
No, tomorrow is Thursday. There's no lecture tomorrow. It's free.
Yeah.
Yes.
So
excuse me, please. The lecture that we had yesterday, that is Agile, the rules of a team. We don't have it on YouTube, please.
Okay. You said Agile. Okay. I'll inform the team.
Please.
They will put it
that
on
is
YouTube.
the one that said Agile, the rules of a team members. That's the Scrum Master, Justin and me. The one that Mr. Yusuf did for us. We didn't have it on YouTube. We only have the Q and just ordinary audio. So the main lecture is not there, please.
Okay. I'll try and inform them.
Thank you very much.
So, all right. Have a good evening, everyone. Thank you so much.
Thank you very much.